Okay, as promised, one last video for vector components on how to add two vectors together completely just using math, just using trig, Pythagorean theorem, and, well, some more trig, okay? This is the exact same question that we answered, if I can find the page. This is the exact same question that we answered earlier, the very first vector addition question that you did, this one right here. Ant walks 6 centimeters, 125 degrees from the x-axis, then 9.4 centimeters at 332 degrees from the x-axis. You'll see that this is the exact same thing. So my recommendation, if you don't want to add this head to tail, let's say instead you want to do this using just trig, just some math. Here are my suggestions, or here's a suggested process for doing so. We're actually going to have a step 0, and step 0 is make a sketch. Okay, just so you know approximately what the answer should look like. So in this case, we already kind of know what the picture should look like, but my sketch would probably look something like this. I know that I have a vector 6 centimeters at 125 degrees, that looked pretty much like this. 9.4 at 332 degrees from the positive x-axis, that looked more or less like this. We should expect a resultant somewhere in quadrant 1, looks like with a bigger x component than a y component. That's just to get your mind in the right sort of setting for making sure that your answer makes sense. Okay, the first real step is to break your vectors into x and y components. So I'm going to do that off to this side. Okay, I'm going to have, here's going to be vector 1. Okay, and here's going to be vector 2. We're going to have an x component for vector 1. We know x component is r times cosine of theta. And we know that the y component is r times sine of theta. And again, this only works to do it this way if your angles are measured from the positive x-axis. We're going to have the same thing for vector 2. Now, vector 1, let's just take that to be the first vector. It has a magnitude of 6 centimeters. That's our r, that's our hypotenuse, our magnitude, whatever, hypotenuse, excuse me, whatever you want to call it. And the angle is 125 degrees from the x-axis. Oh, another good thing, make sure you're in degrees on your calculator. So this should be x equals 6 centimeters times cosine of 125 degrees. 125 times 6, I get negative 3.44 centimeters. Interesting that it's negative, but we'll keep going. On the y side, 6 centimeters times the sine of 125 degrees. And I get 4.91 centimeters. I'm going to stop there for a second. My x component is negative, my y component is positive, and a little bit bigger than my x component. Does that make sense given our first vector? Yes, it does. 125 degrees is definitely in the second quadrant where the x component would be negative because it's in the negative x direction. The y component would be positive, and 125 degrees is closer to 90 degrees than 180 degrees. So we should expect that y component to have a bigger magnitude. For vector 2, 332 degrees is in the quadrant number 4. So I'm expecting something here with a positive x component and a negative y component, and probably, because 332 is a little closer to 360 than 270, probably a bigger magnitude for an x component than a y component. So I have x equals 9.4 centimeters times the cosine of 332 degrees. And I get 8.3 approximately centimeters. My y component is 9.4 centimeters times the sine of 332 degrees. And that would be negative 4.41 centimeters. So I was right. X component is positive, y component is negative. X component is bigger than our y component. All right, let's keep going here. So we've broken the vectors into x and y components. We have x and y for vector 1, x and y for vector 2. If we had more vectors, we would just keep doing this. Step number 2 is to add the x's and the y's together. So if you imagine, what we're doing right now is we just found the x component for each vector. You can only add, when we're talking about vectors, you can't add things if they're in different directions. However, if things are either in exactly the same direction or in exact opposite directions, you can add them together. If they're in exact opposite directions, one of them has to be negative, the other one has to be positive, and they're in the same directions, they're either both negative or both positive. So what we've done is we've made it so that we can add or combine all the x components together to get what we would call a total x component. So our total x component would be negative 3.44 centimeters plus 8.3 centimeters. And so x total, which I'll just abbreviate xtot or x tot, is 4.86 centimeters. Our total y component would be 4.91 centimeters minus 4.41 centimeters, and that would be a y tot of 0.5 centimeters. So looking at this, my x total is positive, my y total is positive. That means we should get something in quadrant 1, which is what we wanted. And if you remember, the x component much bigger than the y component, that also makes sense with the pictures that we've drawn so far. Step 3 is to use the Pythagorean theorem to find the resultant, because remember we're adding vectors together, so we're getting a resultant. The resultant's magnitude. That's pretty straightforward. A squared plus b squared equals c squared, using the total the total x and the total y. 4.86 centimeters squared plus 0.50 centimeters squared equals c squared. 4.86 squared plus, now 0.5 squared, if you multiply half by half, that's 1/4, right? So 0.25, so I'm just going to add 0.25 and then take the square root. I get that c is 4.89. And again, the reason that's so close to the x component is because that y component is so small it barely adds anything. And our last step is to determine the direction by using inverse tangent. And what that means is to do the following. The direction is equal to the inverse tangent of the y total over the x total. The y total is 0.5 centimeters. The x total is 4.86 centimeters, or excuse me, 4.86. Sorry, not 4.89. Oh, this is ugly. 4.86 centimeters. So theta is 5.87 degrees. Okay? So if we're labeling our resultant, we would write down that our resultant is 4.89 centimeters at 5.87 degrees from the positive x-axis. Okay, there's our resultant. Now, there is one note that I will make. You do want to check to make sure that your angle makes sense. This angle makes sense because we remember it being very close to the x-axis from the previous example. However, if your x component is negative, what will actually happen is your calculator will think, the way it works is it will give you an angle that is completely wrong. It would tell you like 185, 108, or like it could tell you, I think it tells you like negative 176 or something like that, negative 174. It tells you something really weird. in order to fix that, what your calculator is doing is it's assuming where you want the negative, which is not what you want it to do. If your total x component is negative, what you need to do is make sure that you add 180 degrees to only your final angle. Okay? This is only if the total x component is negative. You add 180 degrees to whatever you get here, and that is your final answer, and that would be correct. Okay? Don't add it anywhere else, and in this case we don't have to do it because our total x component is not negative, but if it was, we would add 180 degrees to our answer for the direction, and then it would be right. As you can see, adding vectors using trig is a little bit involved, but the math is not that hard. The process is fairly easy, and it's easily the most accurate way to do this. So that's it for vectors, actually. Next time we talk, we'll be talking about free fall. See you later.